Okay, I want to present you today the different step of wild yeast selection. The traditional way to develop new wine yeast is to select wild yeast from must or wine. To select Saccharomyces cerevisiae yeast, samples are taken around 70% of spontaneous fermentation. If you want to select non-Saccharomyces yeast, you have to take sample earlier in must or at the beginning of the fermentation. After cultivation and isolation, about 20 colonies of strain belonging to each sample of wine, a DNA extraction was followed. Molecular biology allows us to determine if the strains are similar or different. After this identification, physiological characterization was done on different strains at lab scale and experimental cellar scale, which we will see just after. Industrial tests and multiplication and drying are carried out before validation in the field to confirm fermentation efficiency and organoleptic qualities before the next step, the commercialization. As said before, the strains are characterized, studied to select the best. To start, we studied various phenotypic traits like killer activity, hydrogen sulfide production, ERC7 gene, and fermentation capacity in model synthetic medium and in musts. All these tests allow us to select the most efficient yeast for experimental winery scale fermentation. For this study, we characterize you study around 300 yeasts. First, we study killer activity on methylene blue media plates. Yeast with killer activity were identified by a clear zone around the colony and a blue ring because they secrete an extracellular toxin that are lethal to sensitive strain. Hydrogen sulfide production has undesirable sulfurous flower was evaluated by using Biggie agar. The intensity of brown colony is proportional to the amount of hydrogen sulfide produced by the yeast, and ERC7 gene to know the ability of yeast to produce for MMP, as said before by Han. Only strain with a low production of hydrogen sulfide production, level 1, 1, and 2, and with a killer activity are selected. Killer activity is very important positive enological characteristic to compete more successfully in must and wine and to fight sensitive yeast. The key attribute for yeast used in Sauvignon Blanc is to have the ability to convert thiol precursor to volatile thiol, so to have long version of ERC7 gene. It can be seen here and here that only 5% of yeast had this long version of ERC7 gene. First fermentation were performed on synthetic media, and we determined different parameters like fermentation rate, fermentation capacity, and production of sulfur dioxide, volatile acid, and of course desirable flower. 63 strains were used, including 62 pre-selected strains and 1 reference strain. This slide shows the results of phenotypic traits, killer activity, hydrogen sulfur production, and ERC7 gene, and the result of fermentation on synthetic media of 11 pre-selected strains for their killer activity, low production of hydrogen sulfide, and fermentation efficiency, low volatile acidity, and consumption of sugar. Some strains like this have a slight defect, but their capacity to produce 4 MMP is very important for this study. So we pre-selected 12 strain. The next step of this study is to test the 11 selected strain in must Sauvignon Blanc at lab scale with a low pH and a nitrogen deficiency to be sure to select a strain that are efficient in strong, difficult conditions. They were compared to commercial reference that are different zygosity towards ERC7 gene. From this graph, it can be seen that there were no difference in lag phase here and fermentation capacity between strains. And we can see here that the strain 17920 degrades L-malic acid, and it's not a positive enological characteristic for Sauvignon Blanc yeast selection, so this strain is not selected for the rest of the study. And we can see that pre-selected yeasts are better than reference to volatile acidity and sulfur and sulfide dioxide. So we can confirm that selected strains are efficient in strong conditions. Good job. Aromatic analyses are carried out to evaluate the impact of yeast on the aromatic and sensorial quality of wine. This graph shows other active value of each molecule. Strain, okay, we have the different strain are very different capacity to produce this different molecule. So produce wine with very different profiles. And we can see a good correlation between isoamyl acetate and 2-phenylethanol and acetates. For example, a strain like this, which produce high level of isoamyl acetate, produce a high level of 2-phenylethanol and acetate. On other hand, there is no such a good correlation between isoamyl acetate and ethyl ester, and there are no link between isoamyl acetate and thiol. Just a little focus on thiol to show the link with ERC7 gene and the production of 4 MMP. And we can see that the 5 strain that have the long version of ERC7 gene produce more 4 MMP. To validate lab scale results, a fermentation was led in experimental cellar in Sauvignon Blanc, and a selected strain with selected strain and the same reference strain that before. And two strains pre-selected from previous experiments confirmed nice result. Low fermentation, low volatile acidity, and low total sulfur dioxide. In all pre-selected strain, the strain 17783 and this strain 17912 show consistent better results than reference. And the wine were evaluated by a testing panel consisting of 11 professional testers and strain the strain 17912 scored higher than other strain for fruity, chiol, and complexity in olfactive profile, and in acidity, intensity, aromatic intensity, and persistence. So this is the best strain. And this strain is also the best in global quality. That's why she is selected for industrial test, multiplication and drying and validation in the field. And Anne will present you this validation just after.